Okay, pre-calc, hope you guys had a good spring break. So we're going to jump back into our unit on trig identities. And today we're going to check out the sum and difference identities. So you can see these guys right up here at the top, sum of angles, difference of angles. And you can also find them on your front page with all your other identities, your reference sheet. So that'll come in handy to have available. The other thing that you should have available right now is your unit circle. We're going to be using this guy. All right. So what the sum and difference identities give us the ability to do is to find exact trig values for angles that are not on our unit circle. All right. So an exact trig value is when our final answer isn't a decimal. It's not like we can plug it in our calculator and just get this long decimal. We want something that is an exact trig value, like all the guys we have on our unit circle, like 1/2, root 3 over 2. Those are considered exact trig values. And so the way we can do this, guys, is we can use these sum or difference identities. So what we're going to focus on today are just sine and cosine for the sum of angles and difference of angles. So essentially what we're going to be trying to do is we're going to be looking at these guys like sine of 105, and we're going to break it up into either two things added together or two things subtracted together. And then we can just rewrite it using that identity. And if we simplify it down, we should be able to get to our exact trig value by the end of it all. Right? So our first guy is a sine problem, so sine of 105. And we're either going to try and break it up with two things that are added together or two things that are subtracted together. Right? So the important part of this is that those two things we decide to either break it up with addition or subtraction, we want them to be on our unit circle. Okay? So, for example, sine of 105. Okay? If I'm looking at my unit circle, 105 could be broken up into 60 plus 45, right? So the first thing I'm going to do is I'm actually just going to rewrite this guy as the sine of 60 plus 45. And the reason I did that is because now I have a situation that looks exactly like sine of a plus b, right? My a is 60, my b is 45. So that gives me the ability to actually rewrite this entire expression just like this right here. So I'm going to do the sine of a, so the sine of 60, and then the cosine of b, cosine of 45, plus the cosine of a, so that's the cosine of 60, times the sine of b, so sine of 45. And the nice thing about all four of these guys is that we can find them very easily using our unit circle. The sine of 60, I go to 60, it looks like it's root 3 over 2. Right? The cosine of 45, I go to 45, it looks like it's root 2 over 2. And then cosine of 60, I go to 60, that looks like it's 1/2. And the sine of 45 is root 2 over 2. Right? And remember, we want to get this into a single exact value. So first off, I'm going to just multiply these. That's going to be the square root of 6 over 4. I did root 3 times root 2 and 2 times 2. Over here, we're going to have root 2 over 4. It looks like we already have a common denominator, so we can actually combine these guys. Unfortunately, we can't add root 6 and root 2, but we now have the sine of 105 degrees. Right? And something you could do just to kind of prove that that's the truth is go ahead and we want to be in degree mode here. Let me see. We're going to go ahead and take the sine of 105. And I got something like 0.9659. And then I'm also just going to do exactly what we got as our answer, which is square root of 6 plus the square root of 2. And then I'm going to divide it by 4. And you see how I got the same exact answer? I got 0.9659 when I did sine of 105 and when I did the square root of 6 plus square root of 2 over 4. So we just got the exact value there rather than the decimal. All right? So for number 2, let's do a similar guy, but then now we're looking at cosine. So we're going to try and either break it up with addition or subtraction in that way. Right? So if I'm looking at my unit circle, 165, I'm thinking maybe 120 plus 45, right? It might take you a minute to figure this out, but you'll get quick at it. 120 plus 45 is 165. So that's how I'm going to break this guy up. I'm going to do the cosine of 120 plus 45. So that's this guy, the sum of angles, right? So my A is 120, my B is 45. I'm just going to go ahead and I'm going to do cosine of 120 times the cosine of 45. That was these two parts right here, minus the sine of 120 times the sine of 45. And remember, the reason why we chose those angles in our unit circle is because we can figure out all our trig values pretty easily. The cosine of 125, I'm getting negative 1/2. The cosine of 45 is root 2 over 2. And the sine of 120 is going to be, looks like it's root 3 over 2. And the sine of 45 is root 2 over 2. And when I multiply these, I get negative square root of 2 over 4 on this left side. And over here, I get minus the square root of 6 over 4. So it looks like I'm going to get negative square root of 2 minus the square root of 6 over 4. I already had that common denominator. Okay, so numbers 3 and 4, you'll notice, look a little different. We have radians instead of degrees. Right? It's kind of annoying to deal with radians because you got a lot of common denominator work you have to do. So what I suggest is actually going ahead and converting these guys. So remember, all you have to do to convert from radians to degrees is take your radian, so 19 pi over 12, and multiply it by 180 over pi. Okay, so the pi's are going to cancel, so I'm just going to do 19 times 180. I'm going to divide that by 12. So the first thing I'm going to do is I'm just going to rewrite this as the cosine of 285. Right? And so just for the sake of doing one where we have the difference of angles, there's going to be sometimes you'll see there's like different options, whether you could add, subtract when you're breaking it up, but you'll get the same answer as long as you're doing everything correctly. I'm going to do one where we're subtracting. So I'm going to go ahead and I'm going to break up this 285 as 330 minus 45. Right? And that gives us 285. So this is my A, this is my B, but now because I just broke it up with subtraction, I'm going to use this identity, cosine of A minus B. So that's going to be something like this right here. We got the cosine of 330 times the cosine of 45, and we're going to have plus the sine of 330 and the sine of 45. And then you just go ahead, and remember we can use our unit circle to find these values. Cosine of 330 looks like it's square root of 3 over 2. Cosine of 45 is root 2 over 2. And then right here we have sine of 330, which is negative 1/2, and sine of 45 is root 2 over 2. So you should got root 6 over 4 when we multiply those together. And then we're going to have plus negative root 2 over 4. So I got something like this right here as my solution. Okay. So number 4, you'll notice we have another radian, but we also have negative. So I'm going to go ahead and I'm going to first convert this guy. So remember, that just means I'm going to take negative 5 pi over 12 and multiply by 180 over pi to get it into degrees. So that's 5 times 180 divided by 12. I got something like 75. And remember, that's negative 75. So we have the sine of negative 75. Okay. And then we have to go ahead and we have to think of two things that are going to add or subtract to this. So it looks like I got something like this. If I take negative 45 and I subtract 30 from it, doesn't that give me negative 75? So what I'm going to do now is I have negative 45 and 30 as my A and my B values, and I'm subtracting. So I'm going to use this guy up here. So when I rewrite it, I'm going to do sine, and remember this is a negative 45 for my A value, cosine of 30 minus the cosine of negative 45 and the sine of 30. So negative 45, if you're not sure how to do that in your unit circle, remember, that just means I'm going to go this direction rather than our normal counterclockwise. So negative 45 is right here. So when I'm looking for the sine of negative 45, it looks like it's negative square root of 2 over 2. The cosine of 30 is square root of 3 over 2. Cosine of negative 45 looks like it's root 2 over 2. And the sine of 30 is 1/2. So I got something like negative root 6 over 4 minus root 2 over 4. And I get something like that as my answer. Okay, so what I want you guys to do to practice is go ahead on the homework, which is homework 4. Okay, and I want you to try, let's just try numbers 1 through 6. Okay, so give numbers 1 through 6 a try. Hope you guys have a good day.